All right, it looks like we are back. Very sorry, folks, for the technical difficulty. I made some jokes earlier about how I wouldn't run iRacing on my gaming machine simultaneous to run anything else. And apparently, like, I can't even touch that computer. It just completely, it lost it. It's gone. It's completely shut down. I don't know. So anyways, we're back in a slightly different format, but people can see the screen and they can see us. And so we're going to call it a win.
Yeah.
So let's go, Kyle. Pick up where you left off.
Yeah, no, I do feel a bit like the Wizard of Oz at the end where, you know, they realize that he's not this big, great wizard, but just a guy behind a green screen.
You're the opposite.
Yeah. Like, oh, I wasn't cool to begin with, but now I'm just a guy in front of a green screen. All right. So Harnett, so we've got the ingest.us1.signalfx.com, and that's our endpoint then that we're going to send the data to, correct?
Correct. Can you hear me okay?
Yeah.
Oh, perfect. And then, so you're essentially creating a SignalFX object. And then what you're saying is, hey, I want to use this as an ingest key. So I don't want to interact with the REST API. I don't want to send anything, but I want to send in metrics. So I'm going to use it as an ingest client.
Okay. So the ingest client then is only specific for the metrics, correct?
You can also send traces and events with it, but in this case, we're only using it for metrics.
Right. Okay. So then what I did is I expanded out this is a Python dictionary. And basically what we did is we pulled through the values that we thought were unique and interesting during the virtual race to .conf last fall. And I went ahead and dropped these in alphabetically. Now, you may find some online that you think are pretty interesting, and that's great. Grab those, drop them in here and see if they work. One thing I did find specific about the way I wrote the script, which I'm sure if we let Harnett take a look at it for a couple few minutes, he could find some bugs there. But we're only putting metrics in this Python dictionary, so it has to have and a metric by that to me, would I guess be a floating point value, right? So something that can have a decimal in it. It doesn't have to be a whole integer where it's just a solid number, but a floating point. So like 19.5 is allowed. Anything like that. So things like our speed, RPM, percentages are cool like that. So yeah, so all those are then is it's just an empty key value pair that we're gonna send in. And Harnett, this looks exactly like what you were talking about with the structured data ingestion point. Now, one thing that I pulled too was a Boolean value, and a Boolean value is coming back true or false. So things like, is the car in the garage or on the track or, anything like that. I didn't have time this week to build out that part of the script. So spoiler alert, we're going to set that up then. If you're interested in that from a homework perspective, we'd love to see how you can come up with that. Maybe next week I can sneak on Discord and live stream through me stumbling through it and see what we can come up with as well. Harnett may steal some time and see if you can give me a hand with that too.
Anytime.
Yeah, awesome. So what we've got here too is a class state, and what this is Kudu called this out as a best practice to start it up as IR connected as false, and then we've got a counter. And one thing I want to do is stop and give a shout out to Tim Hard, who's a teammate of yours, Harnett, who helped me with the script earlier this week. He was hoping to be on today, but had to take some personal time today and go on vacation, as people do, I guess.
Tough deal. He's in Hawaii. I feel terrible for him.
I know. Yeah, can't feel sorry for him.
If my green screen was working, I could be there too. But yeah. Awesome. So, anyways, Tim helped us set up then a counter. And what we thought was interesting about this is we're using then the counter to be able to call out lap times, or excuse me, lap counts. So what we thought was interesting then was we wanted to break events by lap count, because we noticed, hey, time as time flows in hours and minutes works for metrics, but when we have time in a simulator that needs to be following lap times, we needed an event to happen. And my apologies, we also did get the cat today as well. We're steering this ship, aren't we?
Oh man, it's going great. We're doing fine. Everything's fine. I wish you had that background. Everything's on fire.
Yeah. Next month.
Yeah, no kidding.
Yeah. So then what that does is that helps break the events apart, and we'll show that then when we get to SOT. And then we have check iRacing, and this is just checking that, again, that iRacing is running, that the simulator here is connected and going. And we could see some of that from the script before, or from my little bit of IR integrating into the Python terminal. We also did some logging here, where we're just printing it out into a command prompt here, or a command screen, so we can actually see what's going on. We have the lap counter. And Harnett, one thing I wanted to ask about here was we have dimensions of data. Can you explain a bit around what a dimension of data is and why that's unique?
Yeah. So dimensions, you can think of them as just additional context, right? So you are sending in a metric with a metric name, and you could be sending it from 10 different cars. How do you differentiate between them? And the way you do it is through this key value pair, right? So you say car, different car for each metric and for each driver. So similar to what you've done, right? Different drivers, different cars for different lap. You just send in unique key value pairs for them and make sure that you can differentiate for the same metric. So because, right, you're checking the temperature, or you're checking something, the same metric for different set of drivers and different laps, and dimensions help you do that.
Gotcha. Okay, so it's kind of a little bit like metadata then, or some constants that we would want around that data then to be able to start to correlate and group things together.
That's exactly it. It is metadata. Yep.
There we go. Hey, nailed it.
Nailed it.
Okay, so then here we've got a bit of the data around sending a metric, and what we've pulled in here is the IR JSON lap and the session ID. So as we do send some metrics, we're getting that extra data. The one thing that I do want to call out specifically and just spend a brief bit of time on, because I know we're starting to run low, is right here. This is really where the magic happens of getting the key value paired data pushed together. So what's going on here is we have that Python dictionary, and key value in the JSON dictionary items run that IR of the key. So much in the same way that we ran that Python command prompt of IR speed, and then it returned that value, we're basically taking that metrics dictionary and just going, hey, that left column, run that command, and then store the return next to it, and then just bounce through it all. And Harnett, there might be a better way to do that. I'm not sure, but this seemed to work for us, and we were pretty happy with it. So if you end up thinking of one, let me know, and we can redo this. But it works. Hey, if you're listening in and you're going, hey, that's not at all how I would do it, I'm going to rewrite it, please do that. We'll pop this up on GitHub so you can fork off of it and contribute back to it. However you want to handle that. We're not proud people here, so please help make this better. We just like racing and getting some data out of racing and some cool visualizations. Now, as well as what we've got is printing that, hey, iRacing has started, so we can see what's going on, the lap counter. And then another thing here that we do is as the metrics get sent and pulled in from iRacing, then sent to Splunk Observability Cloud, we have the script sleep for 0.3 of a second. So we're actually only pulling in data 3 times a second. And Corey, I changed this on you, so I apologize. It was 6 times a second, like you said. I changed it.
You just made me a liar on social media, but it's fine.
Hey, if it's on social media too, it's obviously true as well.
Yeah,
so,
it's true.
Yeah. So anyways, you can set that to whatever you'd like. If you're only interested in half-second data, if you want 10 times a second, knock yourself out. Try it. Play with it. See what you get. The one thing that you need to call out is just that the maximum amount of times you can do is 60 hertz or 60 times per second, because that's the refresh rate of iRacing. So don't do more than that. But if you want to change that, have some fun with it. Let us know in Discord what you get. I'd be interested to see. I've always kept it around 0.3 of a second because that's been fun for me. Now, we've got all the data. We've got iRacing running. Here comes a moment of truth for the great wizard. Up here in VS Code, you can push play, which will run the Python file in terminal. And this will send out the data from the script. And as you can see here, we've got timestamps rolling. So here we started it. iRacing started. IRSDK is connected.
It's running.
We are looping through the script.
It's running.
So, yeah, which is great. So, and if you notice too, 3 times a second is what we've got it set to. And if you want a different format, you can change it within there, within the print statements. There also is some debugging that Tim set up for us as well that we can take a look at. But there we go. So we are actually looping the data in. Now, we can jump into Splunk on call, or excuse me, Observability Cloud, and see this data start to flow. So kids don't text and drive, but we will drive and look at observability. So I'm going to kick my foot on the gas, and we're going to see some data move. Oh, looks like I hit a bug with some of the data there on this visualization. I'll have to fix that. But what we've got here with RPMs is we've kicked it up, and then you can actually log into RPMs here. And one thing that I thought was interesting, Harnett, was it's as easy as just iRacing dot, and here's all of our data. And then we set the max by driver, but this is where the dimensions can come in, right? The multi-dimensions.
Yes, yeah. So like in this case, you're actually already filtered down by yourself at the top. So if you look up there, there's an overrides. You're going to get data only for yourself. But if you choose to turn that off, I think you have to go back, or
Okay.
Nobody else is sending in data. So if Corey or somebody else is sending in data and you send me that steering wheel and you want to look at the minimum, then I'll probably show up. But that's the way to do it, right? You want to filter, and then, or you want to apply your dimensions and then do groupings by those dimensions. So you can do things like maximum by driver, by lap time, anything like that. Like that's where the dimensions come in. The more metadata you add, the more groupings you can do with the data set.
Okay.
Nice.
Yeah. So
hey,
then
a couple questions, just FYI. Coming in on Twitch again, lively chatter. I really appreciate this. One question is like, how similar is this to what McLaren uses? And I kind of wrote this in a response, but basically, we really can't speak to what McLaren's F1 team is using. But this is absolutely the kinds of capabilities and the kinds of things that we're partnering with McLaren's shadowy sports team to build. And so as a technology partner of both McLaren's F1 team and their esports endeavors, we're absolutely working with them to build the ability to pull data from the platforms of interest to them. We started with iRacing, but if you watch the V10 R League, the McLaren's participating in, that's done on Assetto Corsa. And so we're certainly setting our sights on building, similar capabilities. One thing to call out is this iRacing platform is unique in that a lot of the racing platforms adhere to something called a UDP, and it's kind of a more universal data output process that is a bit simpler to ingest. And you can actually if you type in Splunk app, there's actually you can look up F1 Codemasters. So our team actually created an add-on and an app that uses the UDP port on F1 Codemasters to ingest data from that game. And much of the things that they built in that F1 Codemasters app and add-on, you could actually port that to Assetto with a little bit of Assetto Corsa with, a little bit of work. And it's absolutely something that like the Shadow team is looking at that. And even Tobin said it in the first hackathon that there really hasn't been a ton of work done to bring, sort of data insights into sim racing and even close to the level that it has in real sort of, in-person racing. So, tinker with it. Like if you build something cool, there's a good chance that we're going to show it to the McLaren team as part of this process. So yeah, just wanted to say that. Also, one other question was, oh, sorry, go ahead.
No, get some feedback from Tobin on it. See if it,
exactly.
Yeah, awesome.
That's why he's here, right? One other question was, will we ever get to auto lookups for metrics? Oh, you mean like just turn it on and it just auto recognizes what's coming in? I mean, that's the idea someday for all data, just for AI to know everything.
Yeah. So what we've got too, Corey, is we pre-built this dashboard with Tim, and we pulled in some of the data that we thought would be interesting before we had our conversation with Tobin. I think one thing that we can call out too is under that speed that we talked about, Harnett, is we pulled in the iRacing.speed, and then we Googled the conversion of meters to second to miles per hour, and we did that. Now, what we realized too is, hey, you can just show then this plot and then name it speed under, I think that was chart options. Or no, it was over here.
On the editor itself. That's
figure
right.
plot. Yeah, miles per hour. Yeah. And then we were able to then have our own view there, which we thought was pretty cool. Now, if you are playing with this and you're not seeing your name down here as you build it, you'll see your name populate. Obviously, it's just me playing right now, and that's totally cool. We'll, when we had the race going earlier this week, that was populated with a few other racers, or we can go back in time and take a look there as well. Now, I know we talked a bit around what we thought was interesting and how that was a bit of a shift from what Tobin wanted to see. And Corey actually was able to build this dashboard here, which was literally air temp, track temp, wind speed, fog level, humidity percentage, some skies value, which is where iRacing is actually pulling in the sky value as a metric number, and then we can convert it back. So one thing we'd like to try then is to have the number be indicative of the value to it. And then we have tire temp and tire wear as well.
Yep.
And again,
and actually one of the things to note in that in each of these dashboards, we actually used threshold.
I'm not sure about that.
Did you hear that? Alexa's
yes.
talking to me. I forgot to put her on mute while the call. It's funny. So one thing to note on these visuals, I was tinkering around based on Tobin's feedback that when we had the conversation, and these metrics were available. Some of them we actually hadn't put in the script, in the original script when we were building, because we were being, as Kyle said previously, like sort of selective with the numbers of metrics and the things that we chose. And so we just added those metrics as stanzas in the script when we identified going through that VARS table, ones that we thought were, would solve the problem that Tobin brought up. Because no, we're not kidding. We had the conversation with Tobin and we were like, oh snap, he wants very different things than where our minds went. And so we built these. And what you're seeing here is like that skies value is a numerical integer value that I've just simply put thresholds on in the dashboard to give a color indication that matches what it would think. So like this blue color it's a blue sky outside. It's a blue sky day, right? And these tire temps and other things are temperature visual indicators of cold tires, green, which is optimal tire temperatures, yellow when they get into a, kind of elevated state, and red is, man, you're running at a temp that we've seen near other sort of damage situations. And so you have that ability to kind of do what you want. And it's very easy. And I'll say this, I know we're a pretty good bit over on time, but it's been a good conversation, not without some technical difficulties. This is one of the beauties of Splunk's observability cloud. It is incredibly user-friendly and intuitive in terms of a UI, that once you have the metrics in, and I know today's been a bit, deeper into the weeds and in the code for getting this data out of a platform that's not easy to get data out of. Once we have the data in, like visualizing it is crazy easy in this platform. So certainly encourage everybody to take a look and tinker with it yourselves.
Yeah, absolutely. And I saw a question around how the McLaren cars interact with Splunk, and I'm not sure myself, but I do know we have a McLaren and Splunk .conf session from last year that you can actually go take a listen to, where they've got some of the team from McLaren and some of the team from Splunk chatting together, where there's probably some pretty valuable information in there as well.
Yeah, it was the race from, if you just Google Silverstone Big Data Beard Splunk, it'll be the first thing comes up. It's a fantastic conversation about the way they do it, and they actually are similar. They're polling at something like, I want to say it was like 60 times a second, something like that, like crazy granularity. But yeah, as somebody said in the chat, it's oftentimes the simplest values that are the most formative. And I want to go back to something that, that we said early on with kind of any data analytics project: serve the business outcome you're trying to drive in the simplest way possible. And as Tobin said, we don't want to put a bunch of this stuff in front of the drivers, but as a manager, he wants to look at this information both in real time. This kind of dashboard would be something based on his feedback that would probably be pretty darn useful to him as a manager in a real-time race scenario. But what you're going to see us do in some of the next conversations and the next hackathons is really where we're going to get into using the data that we ingested in the Splunk Observability Cloud, then using Splunk's investigative capability in sort of this traditional sort of Splunk enterprise or Splunk cloud, you can think of it that way, capabilities combined with IT service intelligence to go pull and look at the metrics data that we ingested here and start to build those capabilities that go further into not only, hey, are there, as Tobin said, are there things that we can look at from an aero perspective and from from other inputs that might impact their settings if they were look at like practice and qualifying data that may change race inputs. We're also going to start building service insights that are going to help, make decisions of, we see something going wrong that could happen based on, this machine learning algorithms identified that this is anomalous. How do we go take action on that instead of like just looking at dashboards? So I definitely encourage everybody to come back. Kyle, I don't want to cut you off, but like, I think we accomplished the objective. We got data in.
Yeah, we've I'm pretty much at the end of my showing what we can do. I hope you feel prepared to do it. And much to your point, Corey, this hackathon was unique in that it does require you to have iRacing installed on your machine. And I saw in Discord there was a question around, hey, do we need that on all of them? The next one, there will be no programming, nothing like that. We'll be in Splunk interface, tinkering with data that will be generated from a few different machines. So please join us again next month, and we'll have that a little less programming next month.
We got to do the hard stuff. And candidly, and I want to repeat this, the hardest thing in most cases is actually getting the data into whatever platform you're trying to use. That's why if you read anything about like data scientists and where they spend 80% of their time, it's really around data wrangling. How do I get the data I want, get it into a platform that I can use to analyze, and then format the data in a way such that my analytics can take place and can be scalable, repeatable, right, consistent. And I think hopefully what you all saw today was we showed you how to get the data in from a pretty complex data source into a platform that once we've oriented the data with, we know what data is metrics, we know what's Boolean, we know it's multidimensional, that we can start to very rapidly build some analytics that are incredibly scalable and that all of you can use and that are consistent and repeatable, that you'll see in the platform. That, by the way, if you can figure this part out, I'll tell you this as practitioners, if you can figure out the gaming data challenge that we just put you through and work through this yourself, you've got a future in IT and you've got a future in observability because solving these problems is a real valuable skill. So definitely check us out. Follow us on Instagram, on Twitter. And we have a challenge for you. If you build cool stuff, if you build cool dashboards, if you like build some racing insights based on the stuff that you think is important, post a picture of it and just make sure and use the hashtag data drivers, and we'll be looking for you. And we've got some fun swag. We got some keychains and some goofy stuff we can send out to those of you who are interested. But I want to encourage you to do register for the hackathons and the races to get your hands on the data, hands on the wheel, and join us for Data Drivers. Quick preview for the next session, Kyle, if you don't mind. Next session for the hackathon is June 4th at 12 p.m. Pacific, same time, same place here on Twitch. but we're going to be getting started with IT service intelligence. So if you want to see Splunk's industry-leading IT tools used specifically on, how do we build KPIs that are interesting to start to give us real insights into the health of some of these racing services and metrics, that's where we're going. It's going to be really fun. It's going to be really useful. And we're going to have even deeper conversations with Tobin to understand how we can help him. So with that, I want to say, one, Harnett, saying thank you so much for joining us today, for briefing us on what Splunk's Observability Cloud is all about. Kyle, it was a pleasure to have you, buddy, guiding us through hands-on how you built the script. And I just want to say thank you all. It's super fun day on Twitch and on Discord. Very active audience. Thank you. If you found it useful, give us feedback. If we did not do something well, tell us. Like, get on the Discord, shoot us a note on social. We want to make this useful to you. And so thank you again, gentlemen. Whatever you're into, be data-driven and continue to join us on Data Drivers. Keep it Splunky, my friends.